a square. And each of the sides is 3 feet. Yes, 3 feet. 3 feet. And 3 feet. And we have to make several cuttings. Now, we could make the cuts in several ways. They must be done in the corner. We could make it, for example, here, or maybe too close to the edge, or maybe like this, or in any way that we can create a cubic box which has no cover. Now the problem states that we have to have the greatest volume that we can obtain from making these cuttings. So we have to find which type of cutting gives us the greatest volume. Named X. So what we have to define now is which one of the cuts we have to make in order to optimize and to have the greatest volume. Here we see many examples. In this one, for example, X is really big here, and here X is not. X is smaller. Here also X is bigger. And now we can come to the conclusion that in order to optimize and to obtain the greatest volume in the surface like this, is making this type of cuts in which X would be really close to the edge. Or to obtain the volume on a cube is volume equals sides to the square, to the cubic, sorry, side and side and side. And we will use we will see which will be the formula for our box.
Now we are going to obtain the equation of the cube. First we need to draw the figure. These are the cuts we are going to make. Each of the cuts is X. So now the equation, if we got that here are 3 feet, the equation will be 3 feet minus 2x, this one that are the cuts, times the other side that is the same, 3 minus 2x, and this will be times x, that is the deepness of the box we're going to make. Now,
and the other side, like we have already explained. And then we solve this, and it will give us 9x plus 4x cubic minus 12x squared. And we have to, this is in function of x, we have to obtain the derivative of that, also in function of x, which will give us 9 plus 12x squared minus 24x.
And now we're going to make the equation equal to 0, and because we have multiples of 3 in every value, we're going to divide everything into over 3, and the two values that we're going to obtain of the general formula are going to be used to make the t-chart, the ID test. And we say that x is equal to 9. And with those two x's, we draw the ID test, and the chart is going to be, we don't have a value that is less than 0, so we're going to use another number. Then this and we obtain that the graph here increases in both of the points, so it's going to be like this. So we can say that the graph that we're going to obtain is a parabola. Yeah. Okay, and the whole equation was made to determine that the x's here, the squares, must be of 1.5 feet long in order to obtain the greatest area.